Hey everybody, welcome to Trigonometry. This is at College of the Sequoias. At College of the Sequoias, it goes by Math 154. If you're at a different college, you'll have a different sequence, but trigonometry is trigonometry and it hasn't really changed, not in a long time. So the book we use is a combination of college algebra and trigonometry. The trigonometry sections are chapters 5 through 8. So I'm going to start with section 5.1. If you're in a different book, it's probably your 1.1. So 5.1, trigonometry. And to start off, we really need to go over some terminology. Okay. So first thing we have, if we have 2 points, and a line connecting them. Let's say this is point A and this is point B. This is called a line segment. If the line goes on indefinitely, doesn't just stop there, but keeps going and has arrows going both ways, this is referred to as a line. And then if we have a line segment, I'm going to do 2 of them. The left side is point A, the right side is point B. If the arrow only goes to the right or the arrow only goes to the left, these are called rays. This line segment here goes by AB, and they either put a full arrow or a lot of people do just the top half of the arrow like that. It indicates a ray. This one right here starts at B and goes in the direction of A. This one is BA. Okay. Sometimes, and this is where a lot of trigonometry comes in, when 2 rays share a starting point, this point right here is called the vertex. Okay. And if we look at this as going, let me draw it twice, because I'm going to draw 2 different things. If we look at it, this side as the initial side, and this side up here is the terminal side, if we rotate counterclockwise, I wanted blue there. This goes by that symbol frequently. We use a lot of symbols. This is the most frequent one. This is a Greek letter. It's theta. And it's Greek. We use a lot of Greek letters in mathematics. Counterclockwise is referred to as positive measure of the angle. And if we go clockwise, is referred to as negative measure. Okay. I'll leave that up for a second. You might want to hit pause, take down notes if I've gone a little too fast. I will frequently pause between pages, give you time to pause and get caught up, okay? All right. So in trigonometry, there are 2 common ways are two common methods for measuring angles. Engineers, scientists, people like that, mathematicians. We like to use something called radians. And that's going to be the next chapter. What's used by everyone, even engineers and scientists, are degrees. So that's what we'll focus on this chapter, chapter 5. So we have a ray. And if I make it go all the way around and it comes back and the ray hits again, so this is both the start, the initial side, and terminal side of an angle. When it's the same, this measure is 360 degrees. That elevated circle implies degrees, just like in Fahrenheit or Celsius, degrees Fahrenheit, they put a little circle up there, it means degrees. So there are 360 degrees in a full circle. What if we only wanted to go a quarter of a circle? How far is that? Well, let's do a little bit of algebra. There's going to be a lot of algebra in this class. You just got done passing some courses. This is some pretty basic algebra. We're going to look at it and doing it as a proportion. If we did the whole thing, this looks like it's 1/4 of a circle. So this is 1/4 of a circle. So let's do a proportion. On one side, we've got 1/4 of a circle. On the other side, we're going to have 360 degrees on bottom. The top is X number of degrees. We don't know how far that is. Solve for X. You get 360 degrees over 4 equals X, which is 90 degrees. So a quarter of a circle is 90 degrees. We'll pause there for a second. This is called a right angle. And they frequently denote it by putting a square. That way they're saying this is exactly 90 degrees. It's not 89.9 degrees. It's not 90.1 because it's really hard to tell by eye. In fact, it's impossible to tell by eye unless you're like, I don't know, the Terminator. So they put that little square to tell you this is a 90-degree angle. It's a right angle. All right, so let's look at the different types of angles we have. So there's 4 ways of looking at it. So I'm going to draw 4 angle setups. And I'm always, from here on, going to go counterclockwise. We will work with negatives sometimes, but usually, primarily, we want counterclockwise. There we go. Get the camera situated with the page. So when theta is between 0 degrees and 90 degrees, This is called an acute angle. We just got done telling you about this one. When theta equals 90 degrees, this is a right angle. If it's greater than 90 degrees, if we go all the way flat, it's going to be 180 degrees. So 90 degrees to 180 degrees. This is called an obtuse angle. And guess what this one's called when it goes all the way to the other side? We've gone 2/4 of a circle. 2 times 90 is 180. Guess what? This is called a straight angle because it makes a straight line. All right. So that's the name for angles. I'll mention them once in a while. Right angle, I'll say frequently. More information you need. 2 angles that add up to 90 degrees are called complementary angles. And it's spelled differently than saying giving someone a compliment or complimentary things at like a hotel. The hotel where something's free or it's given, that's an I right there, not an E. These are called complementary angles. If they add to 180, they're called supplementary angles. So let's do a little exercise. How do we find a complement? How to find complement or supplementary angles. So if our angle is theta, one way of looking at it is theta plus, let's say, another angle x has to add up to 90 degrees. Do a little bit of algebra, solve for x. X equals 90 degrees minus theta. So this would be the complement of theta. Likewise, theta plus x equaling 180 degrees nets us x degrees equals 180 degrees minus theta. And this is the supplement of theta. Okay. Let you write that out, and then we'll do some exercises. Okay, let's take a look at some activities. Our first example, if theta equals 75 degrees, find the complement and supplement. Try to figure that out. See if you can figure it out. We just gave you the equations. I'll pause, or you can pause this thing, work this out. All right, assuming you paused it, the complement is 90 degrees minus theta, which is 90 degrees minus 75 degrees is 15 degrees. The supplement is 180 degrees minus theta, which is 180 degrees minus 75 degrees, is 105 degrees. So that's not all that exciting. There are some things we can do with this when we don't know the angle or we're looking for a value. Let's say we have, this makes a right angle. And we have two angles here. This angle here is 4x degrees. This angle here is 5x degrees. Find the two angles. Oftentimes, if you see these things where they look perpendicular and they don't put the right angle in, you're usually safe in assuming that it's a right angle. Sometimes they just don't put the square in. If you're trying to make sure everyone knows what you're talking about, though, put the square in. If you're drawing a picture, like you're an architect or something like that, putting the square in is not good because it makes it part of the picture. Okay, so what do we know here? We have a right angle. This is 90 degrees. We know that the two angles that add up to 90 degrees are complementary angles. So we have 4x degrees plus 5x degrees equals 90 degrees. We add those together. We have 9x degrees equals 90 degrees. Isolate x by dividing by 9. X degrees equals 10 degrees. So x is 10. Did we answer the question? No. The question's not answered yet. Always go back and see what they're asking. They wanted the two angles. So the angle 1, oftentimes we'll say something like this, or angle A. This symbol denotes angle. Angle A is 4x, which is 4 times 10 degrees, which is 40 degrees. And angle B is 5x, which is 5 times 10 degrees, which is 50 degrees. All right, let me give you guys one to try. Pause it when you do it. Here we'll use a straight angle. There's no symbol to indicate a straight angle, but assume it's a straight angle. Okay, and angle A is 4x, angle B is 2x. Go ahead and try to figure that one out. Hit pause. I have a drink of coffee out of my giant Donald Duck strung out looking cup. All right. I'm assuming you paused it and worked it out. We have a straight angle. This is making a full half circle. A half circle is 180 degrees. So we have 4x plus 2x has to equal 180 degrees. This adds up to 6x, which means x degrees is 30 degrees, so x is 30. This tells us that the 2x, angle A, or sorry, that's angle B. Look at me doing them out of order. I'm reading left to right. Angle B is 2x, 2 times 30 is 60 degrees. Try to put the degree symbol there. If you don't put it, it's not clear that it's a degree. And radians don't have a symbol. That's why you'll see that when we get to the next chapter. Radians don't have a symbol. So if you're talking about an angle and you don't put the degree symbol, everyone that has any experience with angles, trigonometry, geometry, stuff like that, calculus is going to assume you're talking about radians when there's no degree symbol. So you want to put the degree symbol every time when you're using degrees. Okay. Leave this positive if you need it up a little bit longer. Take your notes. All right. So 1 degree is really small. But we can go smaller. Just like 1 minute isn't a very long period of time, we can break down a minute into seconds. Time, in terms of time. That's funny because degrees actually follow that same sequence and in the same pattern. Degrees break down like time. Like an hour does. 1 hour is 60 minutes. And 1 minute is 60 seconds. Same thing with degrees. 1 degree equals 60 minutes. And 1 minute is 60 seconds. They use the exact same words. In fact, if you turn this into seconds, 1 degree directly, every minute is 60 seconds. 60 times 60 is 3,600 seconds. So the symbols we use when we're talking about degrees and minutes and seconds in terms of angles, we have that symbol as the degree. For minutes, we just use a single apostrophe. And for seconds, we use 2 apostrophes, like a quotation mark. And this is converting degrees into minutes. To seconds kind of thing. If we want to go the other way, minutes to degrees, this is 1 degree equals 60 minutes. Divide everything by 60. And we find that 1 degree equals 1/60th. I'm sorry, 1 minute is 1/60th of a degree. And correspondingly, 1 second is 1/60th of a minute, which is 1/3600th of a degree. This is a frequently abbreviated DMS. And they kind of look like numbers, right? Zero, 1, and 2. That's an easy way to remember them. So let's take a look at some examples. We can do basic arithmetic with this. I mean adding and subtracting with angles. And I'll pause to let you write that page. We'll do some examples on the next screen. Okay. Our first example, we have 52 degrees, 34 minutes. And we're going to add to it 41 degrees, 42 minutes. You want to add these separately. Don't treat this as 5,234 added to 4,142. You kind of want to put a little squiggly line through it or separate it in your head, but add each side separately. 4 plus 2 is 6, 3 plus 4 is 7, 2 plus 1 is 3, and 5 plus 4 is 9. We have 93 degrees, 76 minutes. We don't leave it like this. Don't leave minutes or seconds if it's larger than 60. So what can we do about that? Well, we've got 93 degrees, 76 minutes. I can write that as 90. This really means 93 degrees plus 76 minutes. Maybe seeing it that way might help it. Which means I can split that 76 up into saying 60 minutes plus 16 minutes. Did you follow me? This 76 is that right there. And then we convert the 60 minutes to 1 degree. And then we combine the degrees. We end up with 94 degrees, 16 minutes. Okay. The similar works with subtraction. And we're just going to make it difficult right away. We're going to start off with 90 degrees and we're going to subtract 47 degrees, 15 minutes. You want to start on the right, just as I did up above. I've got nothing to subtract from. How can I work with this? Well, 90 degrees equals 89 degrees plus 1 degree, which makes it 89 degrees. This red pen's dying. Grab another one. 89 degrees plus 60 minutes. So I can rewrite this problem as 89 degrees, 60 minutes, minus 47 degrees, 15 minutes. You see what I did there? And then we can go through it, solve it like normal. 60 minus 15 is 45. If you need to borrow the 1, do so. 9 minus 7 is 2, 8 minus 4 is 4, 42 degrees, 45 minutes. So that's how you can do it with degrees, minutes, and seconds. You'll see this frequently when you're looking at navigation, like by sea. The world is broken, it's an orb, so they do 360 degrees, latitude and longitude. I think one of them only does 180, because it's only half a circle. Latitude is the flatitude, it's layered. It only does 180. It's 90 degrees north and 90 degrees south. 90 degrees north, 90 degrees south. But around the globe, around the equator, goes 360 degrees. That's the longitude. And they use degrees and minutes there frequently. But minutes, seconds can be tedious. So we often use degrees with a decimal. The decimal number. So I'll pause it, let you guys write that down. I'll show you how to do that. First example, we're going to convert 16 degrees, 42 minutes, 14 seconds to just degrees. And we're going to round to the 10,000th place. 10,000ths. Okay, so what do we have? We have 16 degrees plus 42 minutes plus 14 seconds. We already showed the conversion rate for minutes. 60 minutes equaled 1 degree. And seconds was 3,600 seconds equaled 1 degree. So we put that together. We have 16 degrees plus 42 over 60 degrees plus 14 over 3,600 degrees. That's, if you throw those into a calculator, 42 divided by 60 is 0.7. And the 14 divided by 3,600, I got 0.0038, and that kept repeating. So 0.03888, etc. So what we have here, when we add them all up, we have 16.70388888. Keeps going. This is the tens place, hundreds, thousands, 10,000s. We're going to round to here. We look at the next one. This is bigger than 5, so we round up. 16.7039 degrees. Okay. Round up. Quick pause for you. I like playing games like World of Warcraft and online MMORPGs. Right now I'm playing Assassin's Creed Odyssey. I went to BlizzCon. Blizzard made World of Warcraft. And I took my friends. And because I was able to get tickets, they usually sell out in minutes, but I was able to secure tickets for all of us. And on the very first day, we went to this shuffleboard challenge where you slide a little disc across a table that's slick with sand. And they had a little bullseye at the end. And the closer you got to the center, the better the prize. We were the first people in line. And since I bought the tickets, they let me go first. And I asked the guy that was holding the challenge, what happens if you're on top of one of the lines where you're kind of in one region, but also in the other? And he says, we will round up to the bigger prize. So me, I got like second or third ring outward from the center. Not so hot. I don't remember what I got, because my friend Jabin immediately after that, he went up and he did it, and his bullseye, let's say these are the rings right here. His puck landed just like this, where it was just over the center. And the guy paused. It wasn't halfway over the center, but it was over the center. And I'm standing right behind the guy. And I see him pause. And I just yell, round up, round up. The dude jumped. He just leaped. It scared the shit out of him. But he realized I had called him on it. He had already said he was going to round up. So he went, and this was like 10 years ago. These were not cheap back then. Jamin got a wireless keyboard that had light up keys. It was like $120, $130 reward at that point. He carried that around all day. There's your quick pause for a story. I will frequently do stories. Okay, let's go the other way. let's go from decimals to degrees, minutes, seconds. And we'll start off with 63.157 degrees. So this is 63 degrees plus 0.157 degrees. And if I want to use the conversion, for every 1 degree, there is 60 minutes. So if I multiply that out, I get 63 degrees plus 9.42 minutes. And we'll separate that. 63 degrees, 9 minutes plus 0.42 minutes. And every minute is 60 seconds. So we got 63 degrees, 9 minutes, 0.42 times 60 is about 25.2. And so we've got, at this point, you dump partial seconds, 63 degrees, 9 minutes, 25 seconds. Round the partial seconds. Just like we really, when we're talking in normal everyday language, we don't break down seconds into like milliseconds or something like that. Yeah, if you're timing something like on a racetrack or a science experiment, things like that, you do break time down. Time is continuous, it does break down. But normal people, hours, minutes, seconds, we do degrees, minutes, seconds. I'll leave that up there for a second for you guys. Okay. So what happens when we put this on our good old Cartesian grid? So our Cartesian grid, you know, the good old X degree or X and Y axis. If we put the starting angle or initial side here, and we rotate it, and this is our terminal or ending side, making an angle theta. And the vertex is at 0, 0. The coordinate 0, 0. We say this is in standard position. And we like using this. We are going to use this a lot, so get used to it. So what do we have here? Let's take a bigger look at it. So we're looking at terminal sides now. So terminal sides. So let's say we have one in this region, we have one in this region, we have one in this region, we have one in that region. When theta is between 0 and 90 degrees, this is said to be quadrant 1. Or you might see Q1, or you might see it in Roman numerals, QI. If we get over here where it's between 90 degrees and 180 degrees, this is quadrant 2 or Q2. Adding 90 to each of these gets us the full lap around, all the way around here. That's theta now. Theta is between 180 degrees and 270 degrees. That looks bad. Let me rewrite that. 180 degrees less than theta, less than 270 degrees. This, of course, is quadrant 3, or Q triple I. They tend to write it with one bar on top, not 3 different I's. And finally, when it goes all the way around into this last region, this is 270 degrees, less than theta, less than 360 degrees. It's following the sequence, quadrant 4, and they don't use 3 I's, they use IV. V is 5. When you have an I left to the left of a number, it means 1 less than it. 1 less than 5 is 4. What about 0, 90 on the actual axes? 0 degrees is also 360 degrees. If the terminal side ends on an axis, we call these quadrantal angles. Okay. Pause for a second, let you guys write that out. Okay. So any multiple, all multiples of 90 degrees are quadrantal angles. Of course, you have your 0 degrees. We got 90 degrees. Our 180 degrees. 270 degrees. All the way around is 360 degrees. And what if we go all the way around and go a little bit further? 360 plus 90 is 450 degrees. Note these two angles have the same terminal side. When this happens, we call it coterminal angles. Coterminal angles have the same terminal side, but different numbers of rotation, but different rotations. So the top one didn't have a full rotation, the second one did. So you got 0, 90, 180, 270, 360, which goes over here because that's the same angle. You've got 450, 540, 630, 720, 810, 900, 990. How did I go through that so quick? If you dump the 0, these are all the multiples of 9. 9, 18, 27, 36, 45, 54, 63. If you know your times tables, you can do these pretty quickly. We usually don't want these. Usually don't use them. Sometimes it's important, depending on if you need to count the number of rotations. But since they end up in the same spot, knowing what happens at 90 degrees is the same thing as what happens at 810. Why remember everything past 0, 90, 80, 180, 270, 360? Why remember all the big things when you can just remember the base ones? We really don't use them. This row right here is called the angle of least positive measure. And that's when theta is between 0 degrees and 360 degrees, including 0 degrees. Okay, I'll pause right here, let you finish writing. We are almost done with this section. So these coterminal angles, let's practice finding them. Finding coterminal angles. This is pretty easy. Easily accomplished by adding or subtracting multiples of 360. So in the following examples, find the angle of least positive measure. So our first example, we have 812 degrees. So if I subtract 360 from it, feel free to use a calculator to speed it up. This is 452 degrees. Subtract 360 again, we get 92 degrees. Now, if I were going to try to draw 812 degrees, figure out where the terminal side is on the Cartesian grid, I would have a terrible time doing it. But I know where 92 degrees is. This makes 90 degrees, so just past it, probably even closer to the y-axis than I did. That's 92 degrees. Which apparently I went one circle, two circles, is the same thing as going once around, going around again, and then stopping there. That's 812 degrees. We do use negative angles. If you go backwards, it's a negative angle. So let's look at negative 286 degrees. We'll fix this. We want to make it between 0 and 360. We have to add numbers to it. So here we'll add 360 to it. If you add 360 degrees, that's 74 degrees. So 74 degrees is, I don't know, it's about there. That's 74 degrees. And this is negative 286 degrees. Okay. That's it for section 5.1. It's in a normal class day, I'd get it done in an hour, and this was about an hour. Feel free to work on the homework, and I'll make the next video shortly. Peace.